All right, well, since, as I said, we have a lot to get through today, I'm just going to get us started on time. I'm sure some folks are going to join us, but at the beginning, it's just some of the welcome slides. So I hope by the time I turn it over to the first speaker, most participants will have joined. All right, so welcome. Today is the third training in the series of 4. And the title of this training is What Engineers and Site Design Professionals Need to Know About the Best Stormwater Solutions. And this training is going to be focused on designing best practices. And I just want to remind everyone that this was made possible thanks to a grant from Mass DEP. And this was developed in partnership with Pioneer Valley Planning Commission, the Center for Watershed Protection, and Neponset River Watershed Association. This project was developed to deliver live and on-demand trainings to the Massachusetts development community with the ultimate goal to increase the understanding of how to prevent stormwater pollution and design projects that comply with stormwater standards. So the on-demand trainings that I just mentioned, they'll be available later this summer, and they'll be comprised of a lot of the content that you're seeing during these live trainings. And our intention is to incorporate feedback from participants. So at the conclusion of this training, a feedback survey will pop up on your browser. So if you could please take a moment to complete that survey to help us make these on-demand trainings better and more effective for the community. And to cover today's agenda, we're going to be hearing from Deb Caraco from the Center for Watershed Protection, who's going to talk to us about the best stormwater solutions for your site. And this is going to be the high-end overview. Then we're going to hear from Lisa Rhodes from Mass DEP on stormwater updates to Massachusetts Wetlands and 401 regulations. Next, we're going to hear a case study from Neil Angus. He's from Devens Enterprise Commission. Then we're going to hear from Sandy Brock, who's going to share stormwater in soils, what you need to know, and a brief activity. Then we're going to hear from Theresa McGovern from VHB, who's going to talk to you about using the EPA stormwater performance curves. There's going to be some, these segments will be recorded, so please make sure you're muted throughout the training, these segments, but there will be periodic breaks for Q&A or an interactive activity. And during those times, please feel free to raise your hand, unmute yourself, ask your question, or post your questions in the chat box that our speakers can answer. So to kick us off, I'd love to do a couple of poll questions to give a better idea of who's participating today. So the first question should pop up on your screen is, what type of organization are you affiliated with? All right, we're about 70%, 80% there. Okay. So it looks like we have over half of participants today are engineers or site development consultants. We have several from government agencies and a couple nonprofit organizations participating today. So the next question is, how many people are participating from your location? So based on the list of participants, we have 25 or 26 different participants or small groups. So to get an idea of actually how many people are participating today. All right, we've got, most folks are participating just them from their computer, but we have a couple groups of 2 to 5, and then we have one large group of 10 or more. So to give you an idea, there are a lot of folks on the call. Please feel free to ask your questions. We want everyone to have meaningful interaction with the speakers and to hopefully benefit you all in your everyday work. Oh, sorry, I didn't share the results. Here are the results. Quick snapshot. Okay. So next, I'd like to introduce our speakers. So today, as I said, you're going to be hearing from Deb Caraco, who's the Senior Water resources engineer from CWP. Deb has been a center employee since 1996 and currently works for the center remotely from Ithaca, New York, in the beautiful Finger Lakes region. Her areas of focus include IDDE, pollutant modeling, stormwater design, and data analysis. Next, we're going to be hearing from Lisa Rhodes, who's the program manager and wetland monitoring and assessment, or from wetland monitoring assessment from Mass DEP. Lisa Rhodes has been an environmental analyst with Mass DEP's wetlands program for nearly 19 years. And she's been a primary author on numerous Mass DEP guidance documents and is the primary reviewer of major projects considered for variances of the Wetland Protection Act. Next, we'll be hearing from Neil Angus, an environmental planner from Devens Enterprise Commission. Neil has extensive experience in land use planning, low impact development and green infrastructure, biophilic design, climate resiliency, eco-industrial development, lead for neighborhood development, and high performance sustainable building design. And I know I'm covering a lot of information at once, but two more speakers you're hearing from today. As I said, we have quite the packed schedule. You're going to be hearing from Sandy Brock. She's the vice president and principal from Nitsch Engineering. After serving in a variety of roles at Nitsch Engineering, with over 35 years of experience in the planning and design of sustainable sites, she now serves as the president and director of planning. Her efforts for various private owners and state agencies in preparing strategic site plans and reports have given her a strong background in land use planning to meet local zoning and planning regulations. And then lastly, we're going to be hearing from Theresa McGovern. She's a senior water resource engineer from VHB. Theresa has 20 years of environmental consulting experience with focus on stormwater management and design, hydrology and hydraulics, water quality, watershed modeling, and TMDL development and compliance. She also helped with the creation of EPA's stormwater TMDL implementation support manual, which guides states in the impervious cover method of developing watershed management studies for waters impaired by stormwater. So quite a mouthful, but we have some very experienced speakers speaking to us today with a wide variety of expertise. So before I turn it over to our first speaker, which is Deb, I'd love to do a quick activity. This is called the chat waterfall. What that means is I'm going to pose a question and I'd like everyone to write their answer in the chat box without pressing enter. And then when I say go, I want everyone to press enter at the same time. So we'll get a waterfall of responses from folks. All right, so again, I'm going to ask the question and you'll write your answer, but do not press enter. All right, what is the first thing you think about when selecting a stormwater design approach? All right, so since it's the first thing, I want to snap judgment. I'm going to count down from 3, 2, 1, go. All right, so we've got location, we've got simple, will it work? HydroCAD, groundwater elevation, soils. I see a couple soils, where to put all the water. All right, so these are great first thoughts. What I'm going to do is turn it over to Deb, and she will speak to you more about how to select those best practices for stormwater on your site. Take it away, Deb.
Thanks. Thanks so much, Lee. I'm going to share my screen quickly. Oops, sorry. And okay. Excuse me for a second. Okay. Great. So yeah, thanks so much. I think I'm feeling like my job today is to kind of just point to all these other wonderful speakers we have today. and kind of just going through the key overall things you need to think about when you come to a development site, and kind of, what they're going to be talking about with that. So some of the key things you need to think about.
Sorry, Deb, are you sharing your screen right now?
I thought I was, yeah.
We can't see it.
Oh, no. Thank you. Shoot. I don't know why that is. Sorry.
I can also click through your slides for you.
Yeah, if you could do that, that would be good. For some reason, I'm having a little trouble with sharing it. Thank you. I'm sorry, I'm having a little trouble with my video. There we go. Thanks a lot, Lee. I could see it now. Okay, great. So if you can go on the next slide, that would be great. Thank you. Okay, great. So I think, some of the key things you really want to think about when you're, going to your site are, and I think we probably saw some of these in the chat waterfall. What regulations do I need to meet? I think that's one of the first things people are talking about or think about. How do I need to, how can I reduce the volume of stormwater runoff that I need to manage? I think, as engineers, you're going to know and see as we go through, the cheapest way to deal with stormwater is to try to reduce the amount that you need to deal with, both in terms of water quality and in terms of storm flows. Kind of related to that, but also, again, part of how you're thinking about site development is what are some important resources that I need to protect, and what role can they play in stormwater management? Then kind of after you've kind of gotten through that part, what are some of the best stormwater control measures or BMPs that you're trying to use on your site? And then finally, kind of almost an extra thing to think about is, what other things am I trying to achieve that I can achieve with my stormwater management plan? So you go next one, please. Thanks. So for regulations, we're going to have a couple speakers here who are going to walk us through the details. We have Lisa from Mass DEP who's going to talk about, updating the Massachusetts standards and how they interact with the EPA standards. And if you're available to come tomorrow, we're going to have Newton Tedder from the EPA who's going to talk about the EPA's MS4 regulations. But, another thing to really think about is that the local level, how important local level regulations are. So if, you're thinking about, you're at your site, where am I in the landscape? And it's going to vary based on if you're in an MS4, if you're regulated by the DEP Wetlands Protection Act. Lisa's going to talk about that, but also getting down into those local laws. And Neil's going to give a great example of one town that's, really goes above and beyond. So you have to, think about that when you get to your site. And the last thing is that all these regulations are really moving toward approaches that promote the use of green infrastructure, including both practices that we think of green infrastructure and then kind of landscape scale practices. Next, please. The next thing is, again, this is, you're going to hear this in Lisa's talk. You're going to hear this from Sandy, and you're going to hear it from Neil and Theresa as well in kind of a quantitative way. These site design approaches that reduce the amount of stormwater volume are key for quite a few reasons. First of all, they're going to reduce that volume of runoff you need to deal with. So any way you can decrease your amount of impervious cover, you're going to see this all through today. You're going to reduce that volume, reduce your costs. You're going to reduce the flood risk because you can, provide, again, less runoff volume and also a space for that water to go. You can also use these methods to achieve other objectives. Maybe you have a tree canopy goal. Maybe you have habitat protection. Of course, if wetlands protection kind of is automatically included. And we're going to go into a lot of detail today about a resource people don't always think of, which is permeable soils. Preserving those spots on the landscape where you can get infiltration is going to be really, really key, especially as regulations change. Next slide, please. Okay. So in addition to, looking at the landscape, we're going to be thinking about specific stormwater control measures. Again, these can be infiltration practices. So the first thing we want to do is we're really going to be focusing on achieving groundwater recharge. So there's, several ways to do that, but these practices that, for example, we have infiltration trenches. Some bioretention practices, if they don't have an underdrain, can achieve that groundwater infiltration. This is permeable pavement. You'll see some great examples of permeable pavement. These practices are great. Then you'll see from the standards talk that they can achieve a couple different objectives at the same time. And, again, another key point about these, you need to, try to get these working on or locate these in the best soils you can find on your site. Next, please. Okay. There's another kind of suite of practices to consider. Again, we're going to talk through these in a little bit more in some of the other talks, are practices that are more focused solely on pollutant removal. So these include any practices that are providing filtering, any practices that are, achieving pollutant removal through settling. They may not achieve too much recharge, but they can act as kind of a polishing or other approach to remove pollutants. Theresa today is going to talk about using the EPA performance curves and look through some examples of that. This is just an example of a curve for gravel-based wetland, which is one of these practices. It can be really great for pollutant removal, but maybe doesn't provide that recharge. So they can be kind of part of your treatment train. So, the regulations will include TP and TSS requirements, and you may be chasing other pollutants too, depending if you have a TMDL or just other regional pollutant goals. Next, please. Okay. The last thing is kind of other objectives. We've kind of talked, we're thinking mostly about, pollutant removal and providing groundwater recharge. But, we're also, of course, are always thinking about, how to safely convey extreme floods. We're always thinking about costs. Can we save money? We're going to see a great example from Neil, and Sandy's going to talk about this too, of, ways that you can actually save money by using LID or recharge approaches. Neil's going to talk a little bit too about co-benefits. So, when you're designing practices, do they also help with climate change somehow? Do they help reduce urban heat islands? Are they providing tree canopy? Do they help with property values or other community goals? And then just lastly, there's plenty of other benefits that we can think of with practices, but, trying to bring that extra layer into your site design. Next, please. So that was kind of my talk, and I think I wanted to kick it over to Lisa to kind of talk in a little bit more detail about the Massachusetts standards and how they're being brought up to the to be equal to or equivalent to the federal government. Thanks.
All right. Well, thank you, Deb. What a great introduction that was. Good points that you brought up, and many of which are reflected in what I'm going to be speaking about in the next 20 minutes. Let me bring up my slides. Can you see that? Can folks see my slides?
We can't.
You can't. Okay. Let's see. Let's try this.
There you go.
Okay. Is that better?
Yeah, thank you.
Okay. So, good morning. Thank you all for inviting me here today, and thank you for being here. This is a great group, really dedicated to stormwater, you know, here ready to kick off the 4th of July weekend with a little stormwater. Sounds great. I want to also introduce my colleague, Tom McGuire, who I think is here, although I can't find him, but he's here somewhere. He is, you know, helped develop the stormwater standards over all these years, and including being a co-author of the current stormwater handbook. So he hopefully will be available for questions if there are any at the end of this. All right, so I'm just gonna dive in. I'm here to talk about our proposed stormwater updates to the Massachusetts Wetlands Protection Act regulations at 310 CMR 10 and the water quality certification regulations at 314 CMR 9, which are exactly the same. Some of you may have heard me speak about this before. The standards have been developed for well over a year now, but there was a little bit of a delay in the transition between the Baker administration and the Healy administration, but they're now back on track, and we are hopeful to see them going to public comment in the upcoming months, although I can't give you a definite you know, date today, but keep your eyes peeled for that. The main goals of doing these stormwater management updates were to address increasing precipitation, to align with EPA's MS4 general permit, to promote nature-based, environmentally sensitive site design practices, and also to update our stormwater handbook. And I'll be touching on all these issues today. So for those of you who are familiar with our stormwater standards, there are 10. And the main standards that we have focused on in this update are Standard 2, which pertains to peak discharge rates, Standard 3, which pertains to groundwater recharge, as Deb mentioned in the previous presentation, Standard 4, which pertains to pollutant removal, and Standard 7, which is the redevelopment standard. And then in addition, we're proposing to add a new standard, which would support compliance with total maximum daily loads to try to get impairment status off of our waters. So these are what I mostly will be focusing on today. Beginning with peak rate attenuation, which is Standard 2. Our existing regulations require that stormwater management systems be designed so that post-development peak discharge rates don't exceed pre-development discharge rates, and that won't change, but there will be a change in implementation. For new development, our current regulations rely on 60-year-old precipitation data referred to as Technical Paper 40, developed by the U.S. Weather Bureau. And our current standards also require the 2 and the 10-year storms and the 100-year storm, if there's off-site flooding, be evaluated. Our proposed standards will discontinue use of the TP40 Atlas and adopt the NOAA 14 Atlas, initially published in 2015 and updated since. Although rather than rely on the fitted value or the average value, we are proposing to require the upper end of the confidence interval be designed for peak rate attenuation. We're also proposing that the 2, 10, and 100-year storms be designed for in all instances. For redevelopment, the current standard is that you have to meet this standard to the maximum extent practicable and improve existing conditions. And that's not going to change. It will continue to be a maximum extent practicable standard for redevelopment. However, it would be maximum extent practicable of the NOAA plus standard. And this graphic just gives you a little insight on the NOAA, what we selected for the NOAA for the design, peak rate attenuation. The y-axis is the precipitation data. Along the bottom axis is the average occurrence interval. And the 2 dashed lines along the bottom and the top are the confidence interval that is shown in the NOAA Atlas. So that's the range within which storms have been shown to occur. The green line shows the TP40 data, which was back in 1960, and the red line shows what the fitted or average value of the NOAA Atlas is. And then if you look at that dark dashed black line, that is what we call NOAA plus. So it's in the upper part of the confidence interval. So it's 0.9 times the upper confidence interval is what you would need to design for peak rate attenuation. And the reason for this is to reflect the currently observed extreme storms, that are happening more and more, and we've all seen them. So that's what we're, and this is observed data. It's not modeled data. It's not projections. It's actual data. Moving on to standard 3, which is the recharge standard. The standard requires that at a minimum, annual recharge from post-development sites shall approximate the annual recharge from the pre-development site based on soil type. And the current standard bases that on whether your soil is A, B, C, or D, with A being 0.6 inches needing to be recharged, D is 0.1, and then there's a range in between. And we're finding that, this standard in general is not being met. For new development, our proposal is to require that A, B, and C soils recharge 1 inch of precipitation. If you're using the static method, D soils would be 1 inch to the maximum extent practicable. And we're also allowing additional methods that would be presumed to meet the 1 inch standard if used, including the dynamic method and the continuous stimulation method. For redevelopment, the current standard is a maximum extent practicable standard, and that is not going to change. So recharge will continue to be maximum extent practicable for redevelopment. However, it'll have to be maximum extent practicable of 1 inch rather than the current standard. And we are proposing to allow offsite mitigation for the recharge standard for redevelopment. The pollutant removal standard is standard 4, and this is the most important standard that where we need to align with EPA, since EPA has specific pollutant removal standards. For the peak rate attenuation and recharge standards, EPA just refers to the Stormwater Handbook. So it was important that we look at the MS4 general permit and see how we can best align. Our current standard 4 is to remove 80% total suspended solids from stormwater and to treat 0.5 inch for most sites, or 1 inch if you're in an outstanding resource water critical area or a LUPL. The MS4 standard is to remove 90% total suspended solids and 60% total phosphorus, and EPA allows offsite mitigation within the HUC 12. For the proposed standard, the proposed Mass DEP wetland standard is to remove 90% total suspended solids, 60% total phosphorus to align with EPA for new development. And however, we are not proposing to allow offsite mitigation for new development, since the presumption is that your site is pristine and you would be able to design for that. For redevelopment, we currently have a maximum extent practicable standard and improve existing conditions. EPA has a standard to remove 80% total suspended solids and remove 50% total phosphorus. And an off-site mitigation is allowed, again, within the HUC 12. The Mass DEP proposal for redevelopment is to remove 80% total suspended solids and 50% total phosphorus. But we're proposing that this would be a fully meet standard and not maximum extent practicable for redevelopment for most projects. There are exceptions, and I'll talk about those in a minute. And we are also proposing to allow off-site mitigation as long as there's no discharge to critical areas or lupels. So the off-site mitigation would be allowed for redevelopment for standards 3 and 4. We're also proposing to allow use of the EPA performance curves for stormwater control measures, and folks who have used these might appreciate that. If there is an EPA curve, you can use that. If there is not an EPA curve, then Mass DEP has provided credits for different SCMs. So that's all depicted in the Stormwater Handbook. The exceptions for all of the standards, essentially, and some of them are currently, in our regulations, and there's a few new ones. So development that's activities that are not subject to the stormwater standards at all include single-family homes and 4-unit or lot developments that don't discharge to critical areas, emergency projects, and gardens with no impervious surface would not be subject at all to stormwater standards. Projects to remain maximum extent practicable. So these projects would be maximum extent practicable for standard 4 for redevelopment. Include 4-unit or lot developments that do discharge to critical area. 5 to 9-unit or lot developments that do not discharge to a critical area. Unpaved footpaths, unpaved and paved bicycle paths, and other unpaved or paved paths for pedestrian and non-motorized vehicle access. Marinas, boatyards, and roadway maintenance. So the proposal right now would require meeting the 80/50 standard for roadway projects that increase impervious surface. And we have off-site options, like I mentioned, and we have additional considerations for highway projects that are described in the Stormwater Handbook. And then I mentioned that there is proposed to be a new standard for total maximum daily loads, and those are designated plans to clean up certain impaired waters in Massachusetts. Most of this information is already in the Stormwater Handbook, but we've combined it to put more emphasis on the need for projects to meet TMDL standards. And, because the Massachusetts impaired waters list is not getting shorter like it's supposed to be under federal mandates, it's getting longer. So obviously something needs to be done differently. The stormwater, proposal, this proposed standard would apply to projects that discharge to waters that have a TMDL for phosphorus, nitrogen, pathogens, or metals. Or if there's an alternative TMDL that's been adopted by DEP and EPA. The stormwater, what this standard would require is that certain SCMs be used for design in these sites that discharge to TMDL waters. And there's a whole table that's been developed for the Stormwater Handbook that details the types of SCMs that can be used for these types of TMDLs. There's also a tool that's been developed that will help people to figure out whether their site is discharging to a TMDL, and that's on Mass DEP's website now, I believe. This standard also requires that you develop a long-term pollution prevention plan and that standards 3 and 4 be met, whether you're new development or redevelopment. So if you're new development, you would need to meet standards 3 and 4 for new development. Redevelopment would need to meet it for redevelopment standards. Another important thing that I want to talk about is we have a big focus in the proposed standards for environmentally sensitive site design. And so projects will need to evaluate ESSD measures prior to using traditional stormwater design. So that is proposed to be a requirement. The ESSD measures use natural solutions like trees and buffer zones to manage stormwater instead of detention basins and other traditional infrastructure. And towards this goal, we've developed 7 credits that are either new or updated to meet the goal of encouraging environmentally sensitive site design. And we think that by use of these credits, it has the potential to reduce the overall project costs and to minimize long-term maintenance. Shown here is an example of one of our credits that we call the buffer credit. The picture on the left-hand side shows a developed parking lot with the wetland shown in the yellow line on the left, and the buffer zone shown in the dashed yellow line also on the left. And on the bottom right of that picture is an infiltration basin. And in this graphic, the whole parking area has been routed to the infiltration basin. On the right-hand side picture, you see that there's a shaded area to the right of the wetland line. That is the buffer. If there's an existing vegetated buffer there, or if it's not vegetated, if it's like say dirt or paved, it could be restored to a vegetated buffer. And by meeting the specifications of the credit, you could get credit for that buffer, for having that buffer and diverting some of the stormwater towards that. So shown in the graphic, you'll see about 1/3 of the stormwater is being directed towards the buffer. The remainder is being directed towards the infiltration basin on the bottom, which is substantially smaller, so lower cost and lower maintenance. This graphic also uses additional trees, which sort of just to flag that we have a new credit for tree canopy that can also be used. This is a list of the credits we've developed. Credit 1 is to minimize impervious surface. So it's primarily for newer developments where they use cluster development and keep the impervious area below a certain amount. We have a specific credit for solar arrays. Credits 3 and 4 for disconnection, a disconnection of roof runoff or disconnection of driveways, parking areas, etc., into a qualifying pervious area. Credit 5 is tree canopy credit, where you can plant trees or use or protect existing trees, and there has to be a maintenance plan and so forth. Credit 6 is, reducing impervious area, so removing current impervious area, and credit 7 is by using a buffer zone for treatment of some of the runoff. So that's the one that I described a minute ago. So that's just the summary of ESSD. And then finally, I want to showcase the new Stormwater Handbook. It's draft. It will be published on our website when the regulations are published for public comment. You can see on the left the outline of the current Stormwater Handbook, and on the right the outline of the new Stormwater Handbook. There are a number of key formatting changes, including new cover page, table of contents, searchable headings, figures, and tables. So we'll have live links throughout the document. So I'm sure a lot of you who've used the existing Stormwater Handbook will really like that, because it makes it so much easier to find things. Pop-up boxes for key concepts, example calculation boxes, summary tables, updated appendix, which is, so there's a special a page for each SCM that describes, all the specifications for that SCM. The ESSD SCMs are right up front. So that's all updated. There are updated precipitation depths and distribution curves, updated pollutant removal credits. So we, as I mentioned, we're allowing use of the EPA curves. So the curves will be included as an appendix to the Stormwater Handbook. New ESSD fact sheets, I already mentioned that. New TMDL table, I mentioned that. And then once the regulations are finalized, we would launch a new calculation tool that will help applicants develop rainfall depths and distributions for peak rate calculations. We are planning a standalone guidance document for conservation commissions, so a simplified guide for conservation commissions, and then like a full outreach session through both virtual and in person. There'll be plenty of training. So that's all I have. I don't know whether there's time now, but we're happy to take a few questions if there is. Thanks, everyone.
Thank you, Lisa. See, I see a couple questions in the chat box. Because we have a lot of content to go through, we'll take the couple questions, and then there will be more time at the end of the training to ask more questions. So the first question, from DEP standpoint, do you have any recommendations for ANR lots that are 5+ and do not trigger stormwater review until development occurs near wetlands? Comment is, I've seen many times where upland lots get developed first, then the developer who is in the buffer zone gets stuck with stormwater for the sites. Would this be solely on the local permit authority to flag during planning board hearings?
Let's see. I do see Tom now. Tom, do you want to take that one?
Sure. We have this, so if it's part of a pattern of common development, it includes all phases. So if let's say there's like 5 ANR lots, 3 of them are in their buffer zone and 2 of them are out, the stormwater system should be designed based on all 5, even though 2 of them are out of jurisdiction, because it's part of a pattern of common development. So we specifically have a trigger in the wetland regulations. It's been there since 1996 for this particular trigger. It's not a new trigger we're proposing.
No, I'm aware of that. I guess I should have framed it a little differently. Is there a way to proactively address this? Because what I see is that it doesn't end up happening until that lot by the wetland gets developed. So I know it's not new, but it's being flagged more and more by DEP, and
You know,
it
this
ends up,
goes to I think this really goes to the developer and the responsibility of the developer and the engineering community, because we only have jurisdiction over the wetland resource areas and the buffer zones. So if somebody, you know, decides to kind of try to put together a project that only, you know, parses it together in such a way that they're trying to avoid regulations or just through ignorance, where they have most of the development outside of the wetlands, but yet they're routing the water through wetlands, and that one last lot is the one that's in, and then they try to somehow claim an exemption as a single family house lot when it's part of a pattern of common development. That's when our regulations kick in, but we really, you know, the subdivision control law that is a separate law that's administered by the planning boards. We don't administer that law. We only administer the Wetlands Protection Act.
Right, but the EPA, the MS4 permit may capture that.
Yeah, see, well,
If it's an
right, so
MS4
theirs
designated
is just
area.
1 acre or more of land disturbance, so certainly 5 lots will probably almost always involve 1 acre or more of land disturbance.
Thank you,
So-
Tom and Lisa. Did that answer your question, Angela?
kind of, I was just kind of throwing it out there because we have it happen a lot. And I see it across the board with lots of towns. So I'm just trying to find a proactive solution to address it. And I think it kind of boils down to planning board or whoever the stormwater authority is to trigger that somehow.
So Angela, for the
Food for-
1 acre of land disturbance in an MS4 town, how does the A&R lots try to get around the MS4 permit?
Because the A&R lots, essentially approval not required. They're not putting in a road, they're not putting in a
Yes,
drain.
but it's the amount of land disturbance that triggers the EPA permit, not the number of lots. So if someone is proposing 1 acre of land disturbance, it doesn't matter if it's 1 lot or 20 lots. They could all be A&R lots or else, but it's the 1 acre of land disturbance that triggers it. So if they're somehow trying to avoid the 1 acre threshold, something's wrong. Because they are subject to the 1 acre threshold.
It also
Yeah.
is
So
up to the
maybe-
planning board needs to catch this as well, I think.
Well, it might also go, Lisa, to who's administering the local stormwater bylaw that EPA requires.
Yeah,
I mean, it
exactly.
might not necessarily be the planning board. It might be another board within the town, or even the
If it's
engineering department in the
DPW
town.
or Concom.
So-
They don't ever really circulate A&R plans. It's not one of the ones that they're required to send to all the other boards.
I know this is I know it's a really important discussion, and I'm wondering if maybe we could talk about it offline maybe, and maybe send out information to people. Yeah, I know it's an important discussion, and I think we're a little tight on time. Or maybe we
Okay.
could touch on it all at the end. And again, not to push it aside, but yeah, maybe at the end we'll touch back in on it, and in the context of everything else. If that's okay.
Sounds good, Deb.
Thanks everybody. Yeah, again, I know it's an important one.
All right, so next up, we're gonna hear a case study from Neil Angus. So I'll turn it over to you, Neil.
Oh, thanks, Leah. I actually just typed a response in the chat saying, look at changing your local practices and procedures to address those MS4 requirements, whether it's the DPW or Conservation Commission. you probably should be circulating those A&R plans to them to ensure that they are meeting those requirements. But thanks for having me this morning. Again, my name's Neil Angus. I'm an environmental planner with the Devens Enterprise Commission. Devens is a former military base, for those of you who don't know, located about 35 miles outside of Boston. Can you guys see my screen?
Yep.
Okay, great. So about 4,400 acres, 35 miles outside of Boston. It's a Superfund site, so there was lots of contamination. A lot has been cleaned up. But because of that contamination, we had a sustainable redevelopment directive. People wanted to see it develop in a more responsible manner. And nature-based solutions and green infrastructure are one of the tools that we use to help meet that sustainability goal. So I work for the Devens Enterprise Commission, who's the regulatory authority. We kind of operate a unique one-stop permitting system. So we're the Conservation Commission, the Planning Board, the Zoning Board of Appeals, the Board of Health, the Historic District Commission. So it's a one-stop comprehensive permitting system. So it's pretty unique, but other towns and cities can do it too with the Chapter 43D expedited permitting system if they choose, which is modeled on Devens. So we implement nature-based solutions and low-impact development techniques in three ways. We don't just regulate everything. We educate, we incentivize, and then we regulate. Part of our regulations, we require all sites to meet greenfield development requirements. So no matter if there's pavement on them or not, you have to infiltrate and replicate natural conditions. And that sounds like, somewhat what's going to be similar to the updated DEP stormwater management standards. So that's good to see. But we use these nature-based solutions as a tool to meet those infiltration requirements. These are decentralized systems, as you guys probably well know, and infiltrating the water where it lands. So it's very beneficial from that perspective. We provide developers and applicants with specifications to help guide them and not just say, hey, you got to do this, or you've got to figure it out yourself. So we kind of go above and beyond the DEP stormwater management standards and provide additional details, things like biofiltration, swales, landscape islands, vegetated roofs, permeable pavement. These are all being updated, I know. We've used the UNH Stormwater Center at the University of New Hampshire for a great deal of resources. And all our regulations are available online if you want to take a look at them. But just showing you a few of these practices in place. You guys are probably familiar with a lot of these biofiltration landscape islands. This is a parking lot in Devens. It's a 300 space parking lot. There's probably, I think there's two or three catch basins in the entire parking lot. So a lot less money on structures, a little bit extra area on land to make the slope areas to plant and help filter and infiltrate the stormwater runoff. But the key to the development and design of these is proper construction and durability. So you can see here the beginning of construction, they laid down sod to help slow down the runoff coming off the parking lot, and then the jute netting to help reinforce the vegetated slopes, and a stone pilot channel at the bottom. And here's what it looks like today. So it grew in really nicely. It's filtering the water where, closer to where it lands, doing a great job in renovating the stormwater and infiltrating it where it lands. Similarly, in certain projects, larger projects, we require green roofs. So getting into the, integrating green infrastructure into the actual buildings themselves. This is a picture of Bristol Myers Squibb's campus, green roofs on the bottom and vegetated walls on the top to help with stormwater quality. And Deb mentioned at the beginning the co-benefits of these things, reduced stormwater management, reduced urban heat island impacts. We have view shed requirements in Devens. So this building is 90 feet tall, and it faces a sensitive view shed area. So that once the plants haven't grown in this picture up top, but once they grow in, it'll really help screen the building, as well as provide those air quality benefits by filtering pollutants out of the air as well as the stormwater. So it's a win-win for those multiple co-benefits. We've also incorporated some low impact development techniques into our subdivision regulations and road standards. Here's a typical subdivision road, you know, probably 40 to 50 feet wide, way too much pavement. We've incorporated green street concepts into we have a complete streets program, but we've morphed it into a green and complete streets program to try and reduce pavement and you know, make these areas actually better designed for pedestrians. Cluster subdivisions so that you're not doing these large lots where the houses are set way back from the roads, bringing the houses up to the streets. Doing those compact cluster subdivisions, it actually helps provide traffic calming measures as well too, to slow down traffic, another co-benefit. But we can utilize these landscape areas as infiltration measures to again, locally infiltrate the runoff instead of doing, you know, curb to gutter to catch basin to closed drainage system pipes. We're doing open drainage systems along the sides of the roads. And the design I was showing you here was just a rendering of a proposed subdivision in Devens, and this is what it actually was built into. This is a new urbanist type neighborhood full of single families, duplexes, triplexes. They're all mixed together. This road network is 20 feet wide. It's a two-way street. We worked closely with our fire departments to make sure that, and public safety to make sure that they have adequate emergency access, but shortening up that infrastructure with the cluster development, narrowing the roads down helps reduce the pavement, reduce the amount of runoff, and reduce those urban heat island impacts through the low impact development techniques, some of the green infrastructure elements, including street trees as well. So, and it adds to community character as well too. You know, the people that live in this subdivision, you know, are always commenting on how, you know, how beautiful it is. This new urbanist type development has that front porch concept. So it's actually bringing people out into that road or the street, kind of acting as the street as a public realm, rather than having these large lots set far back from the streets. And then people are just off in their backyards doing their own thing. It's a social interaction component as well too, another co-benefit. We regulate rainwater harvesting too. We don't allow, we do allow potable water use for irrigation, but only as a last resort. We require, you know, people to look at if they are, first of all, minimizing lawn areas, manicured lawn areas, and areas that do need to be irrigated. But if they do need irrigation, look at rainwater harvesting. The picture you see in the bottom here is our office building. All the roof runoff from that office basically is used to offset the irrigation needs for our town green, which is right in front. Devens is not a town, but we act as one. So we actually do have a town green as well too. But you know, it's a great way to manage stormwater, to reduce the amount of storage that you, or the volume of storage you need for dealing with stormwater management. Helps preserve drinking water supplies. We spend a ton of energy and resources, you know, cleaning water, transporting it for drinking, and then we throw it on our lawns. It's a huge waste. So this is a great way to minimize that waste. And it's usually cheap and easy to install if you think about it early in the design. Where it gets costly is when it's an afterthought, you know, and you have to re-dig up everything. If the hole is already excavated for the foundation, you know, it's easy to get, you know, a rainwater harvesting tank directly next to the foundation. So planning early in design is a key element. I mentioned education as well too. We've done a few case studies to show that green infrastructure doesn't have to cost more and can cost less in some circumstances. This is that first parking lot that I mentioned, that I showed you a picture of earlier. And, you know, we did a little case study on it. There was reduced pavement, which, you know, helped reduce costs. We did not have as much curbing for the site, so there was a reduction in curbing costs. Almost no stormwater piping. There's only piping under some of the pedestrian crosswalks that go over these rainwater biofiltration landscape islands. There was increased landscaping costs because there is more landscaping, but that adds to the aesthetics. The landscaping, the plants, the soil types are providing that stormwater treatment. So those soil mixes, you know, are a little bit more expensive, but in the end, there's quite a good cost savings for the development because there was reduced number of structures as well too for catch basins. We've also used low impact development techniques as an opportunity to educate developers. You know, when we get a lot of developers coming in and saying, you know, how am I going to meet these stormwater management standards for Devens? And we're like, you know, look at what other companies have done. You know, we show these as case studies, and we actually partner the developers together to show them how they did it on their property and how it can be done on other properties. So it was a great opportunity to mentor. Lot level, residential lot level LID strategies. This is a net zero energy subdivision with basically no stormwater infrastructure needed. The sites are, there's a rain garden in the front, which is accepting all the runoff and treating and infiltrating the runoff from the driveway. The houses have no gutters on the roofs. So they're infiltrating the runoff directly adjacent to the structure. Street trees, reduce lawn areas. This is another cluster subdivision. So great ways to reduce infiltration, reduce impervious and reduce stormwater structures. Deb, I think, mentioned earlier, porous pavement. We use a lot of porous pavement on sites. It really helps provide additional development capacity for the site because you're not wasting valuable land on a giant stormwater basin. We allow the porous pavement in low traffic areas, typically in the parking stalls. You can see here this picture, the drive aisle is impervious and the parking spaces are porous. And this really goes to help with maintenance as well too. The freeze thaw cycles of the impervious pavement cause a lot of cracking with all the porous spaces and the voids in the porous, reduces cracking. I wish I had a picture of it, but I was out on this parking lot in the middle of the winter too, and we had a small snowstorm, and the snow was accumulating on the actual impervious pavement, but it wasn't accumulating on the porous because of that the ground heat, naturally melting the snow as it falls. So reduce plowing, reduce salting, sanding, a lot of great benefits to those. And another issue, co-benefit to these LID strategies, again, I mentioned local groundwater recharge, decentralized systems. You're not creating these giant systems that waste really valuable land. You're infiltrating it where it falls. These systems are more flexible. They're open. They're not our typical closed drainage systems. So they're flexible to these more frequent and intense storms that are happening due to climate change. And the vegetation in them are helping remove pollutants from the air as well to reduce greenhouse gases, and the soils too, the quality of soils. I think Sandy is going to get into this in the next presentation, but high quality soils can actually help sequester carbon as well as infiltrate stormwater runoff. So great co-benefits of good soils on sites. So that's my presentation, and I'm happy to take questions, or if we want to wait till the end. It's good.
Thank you, Neil. If you have any questions for Neil, feel free to put them in the chat box. We're going to keep the presentations moving. And then we can come back to questions at the end of the training, if that's okay, Neil. Awesome. Next up, we have Sandy Brock from Nitsch Engineering.
Oh, thank you very much. I'm going to share my screen and hopefully it comes right up. Please let me know if you can see it.
Yes, we can see it. Thank you.
Great. So I'm really going to have a very focused kind of discussion about soils. Everyone already knows in stormwater management and designing stormwater how important the soils are now. I think it's just going to get even more important just simply because we're going to be trying to actually infiltrate and recharge and also having to remove total phosphorus. Recharge is the best way to do that. And so it's really just kind of reviewing that, a quick kind of review of soils, and hopefully that's just a reminder for everyone and talk a little bit about testing and then get into what's happening with the regs. We've already heard from Lisa about the changes. We'll touch upon that, and then we'll get into some of the details as it relates to the MS4 and Wetlands Protection Act. So everyone probably has seen this section. I'm not telling probably everyone on this call anything new here. We've always had to do soil testing. It goes back, I think probably 2008, maybe 95, for the Wetlands Protection Act. There's standards on how many we have to do. There's a process that's not changing of how we do the assessment of soils and determine seasonal high groundwater. All that is staying the same. I think the thing that I'm going to be touching on is I think it's becoming more important, and understanding your soils when you're developing a site is critical, and it's becoming more critical. And doing soil testing on site earlier is my recommendation. SCS maps are great, gives you that first kind of look at it, but it's really about understanding where you have opportunities to do infiltration, because it's going to be able to serve you in multiple ways. And that's what I'm going to be chatting about. So this has already been touched upon. MS4 requires total phosphorus removal at 60%. On the right-hand side is a curve. You've already heard some discussions about that. And actually, Theresa is going to be getting into this more in detail, just kind of showing you. It's an appendice to an appendix for the EPA for doing total phosphorus removal. On the left-hand side is all the different methods that you can use to remove phosphorus, and I'm going to talk about some more. This is just trying to compile everything to understand where we're at with from the EPA standpoint of the different curves that we have available. And I think it's important to see that you're talking a lot about the infiltration. And when you talk about infiltration, you really see that magical number of 60% is a little bit easier to obtain through infiltration than some of the other methods of whether it's filtration, different ways of filtrating it. But really the infiltration component of it is the easiest way to take that phosphorus, get it back into the ground, but that is totally dependent upon the soils. Now, there's a lot of other options for removal of phosphorus. I think one of the things, if you haven't been working in a city or a town that requires it already, you'll have to understand that total phosphorus is made up of both kind of dissolved phosphorus and also particular bound phosphorus. So not all types of treatment remove the same amount of phosphorus because there's two different types. And on this particular slide, I'm actually showing the jellyfish, which is kind of a common thing to rely on if you can't infiltrate. And it's a cartridge system and it's activated filtration system that helps to remove the phosphorus. And so once you go away from the nature-based systems into a more of a structured, gray structured system, you have a lot of post-construction of maintenance and so forth because it's a filter system whether it's a sand filter or like a jellyfish like this, the cost is higher, and also the maintenance long-term is higher. So this is the trick when we're looking at removing phosphorus, is to understand that it comes in different forms. I'm not going to get into all the chemistry of it, but basically, if it's dissolved, you cannot just, take it out through particle separation. You either have to absorb it or you have to take it out through precipitation. It's a chemical reaction. So we all have to become more familiar with that. So depending upon where you've been working, I know a lot of folks are probably very familiar with this and have done it previously, but it's now going to be, commonplace to do this. And again, just touching on, these have already been talked about: phosphorus removal, total suspended removal, and looking at, all the different ways that you can do that. And this is through the Wetland Protection Act. And obviously you heard Lisa up front talking about the changes. And again, we're looking at the way we can do, TSS removal and total phosphorus removal. You can see that you can do TSS and phosphorus removal using the same kind of nature-based systems. And one of the other changes that is happening is, what you need to recharge. And Lisa talked about this up front. You're looking at, and depending upon the soil type, the A soil is very sandy to a D soil, clayey, not infiltrating. And this is what the current requirements are, is that for each area of impervious, you have a depth over it, that gives you a volume, and that's what you have to recharge. And so I just went through kind of a very simple exercise to have a baseline so people can understand what the changes are going to result in, and why soils is going to become so important when we're talking simply about some of the Wetlands Protection Act changes. And, obviously that change is to go to 1 inch. And for the D soils, obviously it's always going to be maximum extent practical, but again, it's 1 inch across the board. And so what I did is I just took a very, very simple case study, basically just to show the different amount of volumes that we're currently dealing with and what we will be dealing with, and how the types of soils on your site actually impacts the amount of structure or infrastructure that you would need, and how you can offset that through nature-based systems. First of all, when you look at the ABC currently, it's based on the recharge depth and so forth. When you're looking at a very simple case, 10,000 square feet of new impervious, you can say whatever it is, you about need 500 cubic feet of storage. And then for B soils, it's 292, and for C soils, it's 209. And obviously that has to do with the depth that is currently in Wetlands Protection Act. And when you look at changing that to the 1 inch, that then bumps up to 833 for A, B, and C. And so again, how you design things is not what I'm going to show you. It's really just a way to equate it, to kind of reemphasize how important it is to do your due diligence, look at the soils, do on-site soil testing, and really find the locations where you can infiltrate. So you do this early, and you do this prior to setting buildings and everything else. It's part of the planning process, is to really understand the soils. So let's kind of take this case a little bit further, and let's just keep with the existing regulations. And if you have 10,000 square feet and you want to reduce your groundwater recharge, do your groundwater recharge in 24 hours. That's random. Regulations say 72 hours. I just picked 24 hours as a way to compare the different soil types and what you need as far as the size goes. And so if you want to drain something within 24 hours, the key factor of that is actually the footprint of the bottom of your system, because that's where the recharge and your flow out happens. And so this is just a way to equate things. And so when I looked at this, I happened to use the lower end of the range of each of the soil infiltration rates. So for A soil, I use 2.1, 0.52, 0.17. Of course, D soil is 0.02. It almost is 0. So again, looking at how long it would take to drain in 24 hours, that 10,000 square foot impervious, you know, it's 104 feet for the A, 281 for the B, 613 for the C. And again, this is just to demonstrate what the changes are. And when you look at changing everything to, you know, a 1-inch depth, again, doing that same calculation, everything's static. And again, this is assuming dead storage. This is not being creative in how we're doing our approach to infiltration. Very basic, but you can see that now that when we go to 1 inch, you know, the square footage of what you would need in a kind of traditional infiltration system that has dead storage would be 173, 801, 2400. And again, you can see based on the soils, it's either, you know, 1.6 times up to 4 times the size of the bottom. And again, this is just to let people know what these impacts are. And to say that, you know, you really need to understand the soils and you really want to investigate kind of your green infrastructure approaches where you can take credit for that recharge instead of just putting into a static, you know, infiltration system that you're just using a traditional kind of dead storage and you do the calc for 24-hour storm. One of the things that is really important to understand is that once we start increasing that amount of recharge, we take care of the phosphorus. If we're collecting the surface impervious area going to the system, and if you're doing that recharge for that 1 inch, guess what? You're actually taking care of removing your phosphorus from those impervious areas. So one of the key things is that we want the soils to have multiple functions. And the more we can use different approaches, whether it's infiltration, whether it's, you know, nature-based systems, bioretention, other things, we want to look at it and not just one regulation at a time. We want to look at how can we have multiple function. You know, Neil talked a lot about, you know, other benefits that you have. Well, we need to look at these new regulations so to see what not just the co-benefits are, but to understand how we can look at the functions and do it holistically to reduce that impact on what our structure is going to actually be. And again, this was really a concentrated thing, and you know, there's a lot going on here. One of the things is that when you look at the proposed change to 1 inch, this is not unique to Massachusetts. Connecticut just changed their regulations. New Jersey has changed their regulations twice in the past 2 years. Maryland is just about, they're in the process of changing their. This is in response to climate change and a lot of things that's going on, and the water quality component of it obviously is responding to the continued issues with you know, the amount of pollutants in our waterways and so forth. But it is important to understand as engineers, you know, using the static method is not going to be the only way to determine how we comply with that 1 inch recharge. There will be new options as far as how you do your calculations, whether it's continuous simulation. So be prepared for that, that with the regulations coming, I know DEP has already looked at other alternative methods of calculations, that, you know, we shouldn't be just keeping the way we've done things for the last 20 years. We need to also change as engineers with the time and start looking at how we take all of the holistic approach using nature-based systems and how we incorporate that into our calculations. So we're not only meeting that increase in recharge, but also the, you know, that recharge that will take care of our phosphorus removal. So it's really thinking about soils in a very different way that, oh, sorry, I have a visitor. But in a very different way where those should be the workhorses. So when you're looking at a site, you know, we're all very familiar with till sites and sea soils, we're going to have to become very creative and really understand and really pay attention to our site planning approach way before buildings are set, parking lots are set. We need to understand that site so we make it an efficient site and actually be able to meet all this. That's my very concentrated little take. If anyone has questions, probably happy to answer them at the end.
Thank you, Sandy. I'm going to ask that if anyone has questions for Sandy to please place them in the chat box. And Sandy, if you could respond to some questions in the chat box while we move forward with Teresa's presentation, I want to make sure she can get through the full 10-minute talk.
Hello.
Thank you.
Yes, let me get this up. Tell me if you can see the presentation and I'll start it in presentation mode.
We can see it.
Okay. Let me get it going. Can you still see it the right way?
Yes.
Okay. Yeah, I know we're running out of time, so thank you for staying on. I'm gonna probably just get through my presentation and we might go a few minutes over just to make sure the recording has everything in it. But I'll try to get through quickly. I did just put in the chat a link to the New England Stormwater Retrofit Manual, which a lot of this is discussed in. But today I'm going to be talking about EPA's SCM or Stormwater Control Measure performance curves, and you've heard a lot about them today so far. So I'm just going to step through what they are and how to use them really quickly. So here's an example of the one curve for the gravel wetland. And these curves explain how much pollutant reduction you could expect from a given stormwater control measure on an annual average basis. The x-axis is sort of the relative size of your BMP or stormwater control measure. It's the runoff depth from the impervious area. So you would take your design storage volume of your control measure and divide it by its contributing impervious area, and you get that normalized runoff depth, which is this x-axis. And that's a way to normalize it so we can compare and create these generic curves. The y-axis is then your percent removal. And EPA developed these curves for a suite of pollutants that you can see on the left. And in addition to those pollutants, we have a curve also in the retrofit manual for effective impervious area, which combines phosphorus, phosphorus, TSS, a runoff reduction, and a peak rate reduction, all in kind of a combined metric. So these curves you'll see in the MS4 permits in Massachusetts. As Lisa explained, they'll soon be in the DEP standards. You'll see them in the bylaws for the MS4 communities that they've had to implement. So, and beyond in New England. So they're popping up everywhere, and including this retrofit manual, which we've tried to kind of consolidate some of the guidance on them for. Here is a list of the different control measures that have curves for them now. So it's a suite of control measures, and as I'll show in a minute, you can also line up different curves for different measures. What's nice about them is you can kind of glean some information from them. Not only can you just use them directly to tell you what's going on with a given control measure at a given size, you can also kind of see the relationship. And as you'll see, that it's a curve, it's not linear. So therefore is sort of a knee on the curve, especially for certain ones. It's really an obvious point where the cost benefit, or sort of the benefit of getting a bigger and bigger control measure starts to reduce as you get bigger. The pollutant reduction benefits don't increase. So that's a very useful piece of information as you're doing retrofits or you're in constrained site and you have a more constrained budget and you want to optimize and prioritize. So as I mentioned, these curves can be used for a range of different BMPs. So what we've done in the retrofit manual is talked about the unit operations and processes, or UOPs. So what's actually happening in the BMP? Is it infiltration? Is it filtration? Is it some biological process? And then linked those with a given SCM. I use BMP all the time, so sorry. A certain measure and what you might call it. So you might call something a rain garden. It's doing filtration. So you can use the biofiltration curve for that. That's that middle example. And so we have a full crosswalk that helps align the curves with the different processes and what maybe someone is calling that actual measure. And that you can be seen in the retrofit manual. So I'm just going to step through a couple examples of how you would actually use these curves so we can make a little bit more sense of them. Here's an example of a wet pond. So where that star is, there's a wet pond. And so the first step would be to delineate the catchment to that particular BMP, so what's draining to it, and get some statistics on that. So the BMP, first you would get the volume of that, the design storage volume. And that's a very specific volume that we're talking about. Some BMPs are designed for peak rate control also. So we're talking about what you might call the water quality volume, or it's really the static storage volume that BMP can hold. And so definitions of how you would define that for different BMP types are included in the retrofit manual also. So you would need to estimate that volume either from design, or if you're going back to credit something, you'd have to estimate that through measurements. And then you'd have your impervious catchment area and pervious catchment areas, and that, those would just be from your catchment. So then to get that x-axis point, it's that runoff depth treated, you would take that design storage volume and divide it by your contributing impervious area. And we just focus on the impervious area because that's the area that's creating the bulk of the runoff. It comes at it at the faster rate, and that's kind of taking up the volume of that BMP. And some of our analysis have shown that, including the pervious catchment in your calc doesn't change the answer that much, and it just simplifies using the curves by just focusing on the impervious area. So for this particular example, you can do that calculation and see that this particular SEM has a runoff depth of 1.8 inches. So then you go to your curve and you have to pick the right curve. So this is a wet pond. So we chose the wet pond curve. And for this example, we're interested in phosphorus. So we picked the phosphorus line on this curve. And you can find that 1.8 inches on the x-axis, follow it up to the curve, and then across to get your % removal of phosphorus. So that's one example. Another example I want to show is for impervious area disconnection. And this is a little bit different, which is why I wanted to give an example for it. It's a different type of curve. And this type of measure is where basically impervious area is having the runoff from that impervious area is sheet flow over a pervious area. And it could be called, sometimes it's called, vegetative filter strip or qualifying pervious area if it follows some other requirements that you might see in DEP's handbook, or, for EPA, MS4 and the bylaws and in the curves they have, it's kind of this more generic term of just impervious area disconnection. And so, from an aerial view of this example, we have this roadway that sheet flows into this forested area before maybe eventually getting to that wetland. The curve for this measure looks a little different. The x-axis is not the design related to the volume of the measure, because that's not exactly how this works. Instead, it's based on the ratio of that impervious area to the pervious area it's draining to. So the impervious, catchment to the pervious receiving area. And so as you get larger pervious areas receiving the same amount of runoff from the impervious area, you get more removal. And there's a different curve depending on the hydrologic soil group type of your receiving area. So sandier soils, like A-type soils, will be able to absorb more of that runoff than tighter soils. So these curves are a little different. So I wanted to run through an example of how you might use this curve. So going back to our example, we have to do our area delineations in order to be able to use this curve. So the gray area is the impervious area of this roadway, and the green is the pervious sort of receiving area for the disconnection. So we have those two areas there, the impervious catchment area, the pervious receiving area, and we can calculate that ratio, and I rounded just to make it a little simpler. So we have a 1:6 ratio of impervious to pervious. So going back to our curve, we now can use this curve to look up where we are. We also know just based on soil mapping that the receiving pervious area is hydrologic soil group B type. So what we're going to do is find that 1:6 point on our curve. And, yes, it's not totally linear, but it's appropriate enough to interpolate between these points. So we go up from 1:6 on the B curve and go across to see where we're at and see that results in an 81% reduction for that particular measure. So what I'm showing today were two examples of, here's a sample curve. What we did is sort of this blue line where we know the size or the parameters of a given control measure, and we follow that along on the x-axis, go up and see where we are in the curve to figure out the percent reduction. Another way to use these curves is following the green path, where you might have a desired percent reduction of a certain pollutant based on permit requirements or just whatever targets you might have. And so you can start with that percent reduction and say, how big does my control measure need to be to get there? So these curves can give us a lot of information in both directions. So some places where you can find these curves, in addition to some of the regulatory documents that were discussed today, this New England Stormwater Retrofit Manual, which I put the link in the chat to, is where these are discussed more and how to use them and sort of where they came from. Outside of regulatory documents, it's more of a support guidance document that can be used throughout New England. And then the rest of these are actually tools or calculators that include these same exact curves and data. So the next two are EPA's, the Opti tool, and EPA's BAT, which is their tracking and accounting tool used to support MS4 tracking. MassDOT has put these into their water quality data form. UNH Stormwater Center has a calculator, and Rhode Island DOT, also using these curves, has them in their calculator. So this is even just a short list. These curves are being used across New England now and really becoming the go-to approach for doing water quality calculations. And just, to be clear, it's all really the same base data that is being discussed and presented in these different places. So be good to get familiar with them. So if there's any questions or follow-up, feel free to reach out to me and happy to answer those. Get out of here somehow.
Thank you, Teresa. I want to quickly share the contact information for our speakers today, in case you want to follow up. I know that we were at a really tight agenda. We just had so much interesting content to share with you today. But I hope you will join us again tomorrow for our training on post-construction operation and maintenance. So I will leave these contact details up for a little bit longer if you need to write them down. But thank you so much for joining us today. And again, have a nice afternoon, and I hope to see you tomorrow.